Hello, this is Mr. Henry, and welcome to lesson 5.3. Today's lesson is on this thing called point-slope form. We spent a good bit of lessons on slope-intercept form, which was the y equals mx plus b, which is what these get the goofs are about down here. This point-slope form is just going to be another way to write the equation of a line. You might find it easier in some situations, but harder in others. So the center question says, how do I write linear equations in point-slope form? So let's try these get the goofs, and then we'll get on to the lesson. So the get the goof here says write an equation in slope-intercept form of the line that passes through this point with a slope of 9. Well, you can see this is wrong because that's not where slope goes. Slope goes here, so if anything, it should be y equals 9x something. Okay, so let's start there. Y equals 9x plus b. Now it gives us a point. In the last lesson we learned you put the x value in for the x, the y value in for the y, and then you had to solve for b. So that's 18 minus 18 minus 18. These cancel out. B equals negative 15. And now that you have the intercept and you have the slope, you can write it as y equals mx plus b, except it's not a plus because it's a negative 15. This is the equation of that line. Letter B, same deal. They give us slope and they give us a point. Now that at least looks closer. They have the slope in the right spot. Let's see if everything else is right. So I can't verify this is correct. So y equals negative 3x plus b. Let's leave it as a variable for now. We'll plug in this point and see what happens. The x value is negative 4. The y value is 8. That's a 12. b minus 12 minus 12. These cancel out. B would equal 8 minus 12 is 4. Which means this is actually a little wrong. It should be y equals negative 3x plus 4 because that's the intercept, the b. Okay? Now, slope-intercept form, the form we have here, is, in my opinion, one of the best forms. It's the one that gives you the best information. But it's not always the quickest. If you're given a point and a slope, we can actually use the equation for today, this point-slope form, to write an equation without having to do any of this math. It jumps right into an equation. So point-slope form is ugly, but it looks like this. It's y minus y1 equals m times x minus x1. And it says it's an equation of a non-vertical, so it has to have a slope, a non-vertical line through a given point, where m is the slope, so that's normal, and this x1, y1 is a point on the line. Okay. Now, let's see how this works. It looks really ugly, and it's really not that bad. So here it says, write an equation in point-slope form. So remember point-slope. Y minus y1 equals mx minus x1. This is the new one we just learned today. Write an equation in point-slope form of the line that passes through that point and that slope. So here's what you do. First thing, write down the equation. Y minus y1 equals m times x minus x1. Now, m, slope. Got it. Y minus the y point, x minus the x point. And yes, that is a minus a negative 8. So this would be done except for this ugliness in here. We need to pretty this up. We don't have a minus and negative, so we can rewrite this Now, minus a negative is the same thing as plus, so this is really x plus 8. That's done. That is the equation of this line. Notice how we have one x variable, one y variable, no other variables, which means that is the equation of this line through that point with that slope. Okay? So that's why this other equation is used. It's used because it can save time, and if we really needed to, we could actually, and we'll be doing this in one of the later lessons, we could actually change this into point slope form. We can use our rules of solve an equation. We can get rid of the parentheses by distributing, get rid of addeds and subtracts, and we can change this into a y equals mx plus b thing. And it still might actually be less work than what we were doing in that get the goof problem. Okay, letter B. Write an equation of the line in point slope form. So point slope form. Y minus y1 equals m x minus x1. So write the equation in that form of the line that passes through that point, the slope of negative 7. Okay, so slope is negative 7. The x value is 3. Y minus the y value is 5. And there's nothing to simplify there, which means that is literally done. That's the equation in point slope form, where this is the y value from here, this is the x value from here, and the slope is the slope they give you. That's it. We do not need to distribute. We do not need to do any multiplying or solving, because we want it to look like that. So that would be done. Okay. So I have two problems I'd like you to try. Letters C and D. Here they are. Copy them down. Do them on your paper. Pause the video. When you're ready to continue, hit play, and we'll go through them together. Okay, you should be done by now. So let's see here. Well, in point slope form, which is y minus y1 equals m x minus x1. By the way, write this down every single time. Don't skip straight to the answer, because what's going to happen is later on test or quiz, you go, okay, what's point slope form? You go, I don't remember which one that is. But if you get in the habit of writing down the formula every time you do the problem, you'll remember the formula a lot better. So, that's the formula. Point slope form. Now let's plug it in. We got slope of 1, slope of 1. X minus the x value is a negative 2, which I'm going to change that in a second. And y minus a positive 2. Now, remember, minus a negative is really a positive. So y minus 2 equals 1 times x plus 2. Done. Letter D, identify the slope. Did you read it? Identify the slope of the line given by the equation. Identify the point of the line. Well, the slope is negative 4. That's our slope. The point, see, the x value would be here. The y value would be here. That's the point. 3, 6. That's the slope, negative 4. So it's basically the reverse of this. Instead of plugging in the information into the equation, it's giving us the equation, and we pull the information back out, slope and point. There are one question here from the textbook I'd like you to try. Pause the video, do it on your own. When you're ready to continue, hit play. It asks you to write an equation in point slope form, the line that passes through that point with that slope. Do it now. Alright, ooey, not y equals. I'm so used to y equals. So y minus y1 equals m times x minus x1. There's our equation. Our slope is negative 2. Our x value is a negative 1. Our y value is a 4. Now this minus a negative 1, we're going to change into a plus 1. And so our equation is y minus 4 equals negative 2 times x plus 1. Let me try that whole thing again. Y minus 4 equals negative 2 times x plus 1. There we go. So that's the equation of that line that has a point of negative 1, 4 and a slope of negative 2. Now, we're going to learn how to graph an equation in point-slope form. So we're going to come back to this page here in a little bit. So here we have this equation in point-slope form. We want to know how to be able to make this line, because this doesn't look like point-slope form where you have the nice intercept to start with. I'm sorry, slope-intercept form, where you start with the intercept and then you move the way the slope tells you to move. But what this does have, it gives you a point and it gives you a slope. You just have to be able to dig them out from this information. So the first thing we're going to do is we're going to find the slope. Now, slope here. So m equals. What is the slope? Well, the slope here is 1/2. Remember, the 1/2 means you're going to go up 1 over 2. Up 1 over 2. Okay? But what we don't have is a point. We don't know where we start from. Step 2, find the point. Call it x1, y1. So the point, x value, y value. Now, here's the trick. You are not going to just put 2 and 2. You've got to pay attention to the sign. Now, if you remember the original equation, it's y minus y1 equals mx minus x1. This negative sign, or this minus sign, has to be here. So the y value is this, 2. But the x value is not 2. The way we got this plus 2 is this was actually a minus a negative 2. The way I think about this, the way it makes it a little bit easier for me, it might be a little bit less confusing, is when you're picking out your points from point-slope form, it's always the opposite sign of what you see. So this says x plus 2, so it's actually a negative 2. This is y minus 2, so you're actually pulling out a plus 2. It's always the opposite sign of what you're plucking out. So the x value is a negative 2, the y value is a positive 2. That might be a little bit easier to remember and a bit more consistent. So now that we have our point and we have our slope, how do we graph this thing? Well, you start by plotting the point, then move the way the slope tells you to move. So I say plot the point, then move with the slope. Plot the point, then move with the slope. So for example, our point here is at negative 2, 2. There's our point. Now the slope tells me to go up 1 over 2. That's moving with the slope. Up 1 over 2. I'm out of space this way. Let's do the reverse. We should be over here someplace. Do the opposite. So you go down 1 over 2 this way. Down 1, out of space. And now our line looks like this, sort of. That's pretty close. That's the equation. I'm sorry, that's that line. We graphed it. We found our point. We found our slope. We plotted the point. We moved the way the slope told us to move. That's the equation of the line. I'm sorry. That is the line the equation tells us to draw. Letter B. Same thing. Yeah. Same thing. Got to find our slope. Got to find our point. Slope, negative 1/3. That guy is almost always going to be easy to find. It's just given to you. Slope. Point, Remember, this is the opposite of the points we see. So it says x negative 2, positive 2. Y plus 1, negative 1. X value is a positive 2. Y value is a negative 1. It's the opposite sign of what the equation says. So now we plot 2, negative 1. Slope is negative 1/3. For those of you who don't remember, a slope of negative 1/3 means you're going to go down 1 over 3. Down 1 over 2 over 3. Now we're out of space this way, so let's do the reverse over here. So the reverse of going down 1 over 3 this way is up 1 over 3 this way. Up over 3 this way. And I'm out of space that way, so that's our line. And notice how the points are in a nice straight line. Use a book or a ruler or a straight edge or something, or hopefully your freehand doesn't look ugly like mine. And that is the line. Alright, we pulled out our point, we pulled out our slope, we graphed it, we're done. I'm going to have you do one problem on your own. This will be letter C. Copy down the equation, find your slope, find your point, and graph. Alright, so let's see here. Well, I have all this space. You don't have as much space. You just have this little bit here, but I don't need it. Slope equals negative 1/2. Point. See, opposite of negative 2 is a positive 2. Opposite of negative 3 is a positive 3. There's my point. Slope is a negative 1 over 2, so you go down 1 over 2. Down 1. Play pretend it's over there. Kind of reverse. Up 1 over 2 the other way. Ooh, good. I got one. That gives me 3 points. I like to have 3. 2's okay. I like 3, at least. Now, line, and we're done. All right. So the last example here, example 3, these are just more problems of the same thing. Now you see here they give us 2 points. And we want to write the equation in point-slope form. It says use point-slope form. So think about what we need. The name literally tells you, you need a point, we need a slope. Well, what do we have here? We have points, so this one's good. We don't have slope. So we have to find the slope from 2 points, which we know how to do. Then we can write the equation in point-slope form. So let's go ahead and do that. x1, y1, x2, y2. Equation m equals y2 minus y1 over x2 minus x1. That's finding slope. That gives you a 9. That gives you a 3. That simplifies to 3. So my slope is 3. Now, do I have everything I need? I need points. Yes. I need slope. Yes. So now we can write this equation. Y minus y1 equals m times x minus x1, where this is our slope. There we go. And our points go here. So the x point, it honestly does not matter which point you pick. I'm going to pick the one that has positives because I think it's just easier. So I'm going to plug the x value in for x, the y value in for y, and that's done. Remember that trick of when we were doing the graphing, how the point is the opposite of what it says here? So this was a negative 2, we pulled out a positive 2. It's still the same thing. Look, the point is a positive 5, but it looks like a negative. It's a positive 7, it looks like a negative 7. That's still true. Letter B. Same deal. In fact, for this letter B, if you could, I'd like you to try this problem on your own. I'll pause the video, try this problem, see how far you can get. If you get to the whole way to the end, awesome. If you need some help along the way, hit play, let me catch up to where you are, and then pause the video and try a little bit more. Okay? Yeah, go ahead, pause the video, do the problem, hit play when you're ready to continue. All right. So let's see how far you got. X2, Y2. Okay. So you hopefully were able to find slope. M equals y2 minus y1 over x2 minus x1. I don't always write this part, as you see, but it's good to have it every so often. So that'd be 1 minus 4 over 2 minus 6 gives you a negative 3 over a negative 4, which simplifies to just 3/4. It simplifies to a positive. Negative divided by negative is positive. So I have slope. y1 equals mx minus x1. Slope is a positive 3/4. I'm going to use this point because the numbers are smaller. So x minus the x value, y minus the y value, and that would be done. If you used the other point, if you used this point, you'd get the answer of, you'd have the same slope, but it'd be x minus that x value and y minus that y value. Okay, so either answer, this one or this one, is correct. It does not matter which one you pick. You do not need to write them both. They are both correct. It just depends on which point you use when you plug in your point and the slope. Okay? Now this letter C is a bit harder. We're actually going to do this one together instead of having you do it by yourself. It says here, a bus leaves at 10 a.m. to take students on a field trip to a historic site. Okay. At 10:25, the bus is 100 miles from the site. At 11:15, the bus is 65 miles from the site. The bus travels at a constant speed. Write an equation in point-slope form that relates the distance in miles from the site and time in minutes after 10 o'clock. How far is the bus from the site at 11:30? So the two units they're giving us is distance in miles and time after 10 o'clock. So for example, this one here, time after 10 o'clock would be 25 minutes, and the distance would be 100 miles. So let me put that down. 25 minutes, 100 miles. I'm not sure which one's the x and the y. These might be backwards, but I'm just putting down my thoughts for now. And this one, well, they are 65 miles. And how many minutes away is that? Well, from 10 o'clock to 11 o'clock would be 1 hour, which is 60 minutes, plus another 15 would give you 75 minutes. Okay. So I found for each location they gave us here, let me do highlighter. Ooh, ain't that pretty. So for this one here, the time after 10 o'clock was 25 minutes, and the bus was 100 miles away. I thought of that as like those two numbers kind of go together. For the second piece of information, which is this one here, it said at 75 minutes after, this is 75 minutes after 10 o'clock, the bus is 65 miles away. So I took it as those two pieces of information are kind of like 2 points on a coordinate grid, miles and minutes. Now, with these 2 points, could we find the equation of this thingy in point-slope form? Well, the answer is yes. We just did problems where given 2 points where we find the equation in point-slope form. That's all we're doing again. It's just this time it's wrapped up in a word problem. So I can find the slope of this I can find the equation. So let's do that. I'm going to move these two things off to the side. Don't forget your other guy over there. There you go. In fact, I'm going to group them together, make it easier. Alright, so I have that. Now, let's find our slope. So I'm going to call this point 1, this point 2, and let's see, y equals, oh, not y equals, what am I doing? I'm finding slope. M equals y2 minus y1 over x2 minus x1. That gives us 35 over 50. Is it 35? 65 minus 100. Yep. Ooh, and it is a negative 35. So negative 35 over 50. Does that simplify? It does. We can divide by 5. If we divide this by 5, we get a negative 7 over 5. And that doesn't simplify anymore. So, unfortunately, as ugly as that is our slope of this problem. But we really don't need the slope for much. We need the slope to be able to write it into our equation. So think about the equations. Y minus y1 equals mx minus x1. This slope, ooh, I'm sorry. My brain's dumb. Negative 5 over 7. I had it upside down. My brain's dumb here too. If you were confused there, hopefully you were right and I was wrong. You simplify and divide by 5. What am I doing? I said divided by 5 and I'm not doing it right. This divided by 5 is negative 7. 50 divided by 5 is 10. Wow. So, guess I didn't get enough sleep last night. That is the slope. Guaranteed. Correct this time. So we plug the correct slope in here. Now, we need to figure out our point we're going to plug in. It does not matter which point you use, so pick the one that's easier for you. I don't know. I like this guy, this 25 and 100. Simply because I know I can do math with 25 and 100 pretty easily. I don't know. So my y value is 100. See, that's the y value. The x value is 25. So we've now done this sentence here. Write the equation in point-slope form of the line that relates to the distance from the site in time and the time after 10 o'clock. So we did that thing. What we did not do yet, so let me circle him. He's an answer. What we did not do yet, how far is the bus from the site at 11:30? Well, all we'd have to do is plug that information in here. So 11:30, you need to figure out how many minutes after 10 o'clock that is. So how many minutes after 10 o'clock is that? Well, it'll be 1 hour and 30 minutes. 1 hour and 30 minutes is 90 minutes. So at 90 minutes after the bus has left, how far? Well, let's see. 90 minutes, minutes is our x value, so 90 minutes and now we just solve this ugly, ugly thing, but it's still just a math problem. I'm going to work on this side first. So I'm going to do the math inside the parentheses. 90 minus 25. Oh, I'm glad I have a calculator for this. 90 minus 25 equals 65. And 65 times 7/10. You ready for this? We're going to take 65 times the 7, divide by the 10. 65 times 7, then divide by the 10, and it will be a negative. So it was a negative, was it 45.5? Yeah. By the way, that's how you do that This math on a cheapo calci is you take the 65 times the top number, divide by the bottom number. Okay, and that is still y minus 100. Almost done. Add 100 to both sides to solve this equation. And we'll extend it one more time. Y equals negative 45 plus 100. The signs are different. We're going to subtract. So what? Clear. 100 minus 45.5 equals... No, that's not what I said. What did I type in? 100 minus 45.5 equals 54.5. And it would be a positive because there's more positives than negatives. So at 11:30, the bus is 54.5 miles away from, was it the museum? Historical site they're going to. Big, long, complicated problem. You're not going to see many problems like this. There will be a few possibly, but you're not going to see many. Okay? One thing to realize here, and this happened in one of the other problems as well, is they gave you two pieces of information. 10:25 is 100 miles away, and 11:15 is 65 miles away. Realizing that those two pieces of information could be interpreted as 2 points on a coordinate grid. We had that one other problem, I think it was in the last lesson that happened. Now we had those 2 points. From 2 points, we can do some stuff. We can find slopes. We can use the slope then and one of the points to write the equation in point-slope form here. Then it asked us how far away the bus was at an hour, or at 11:30, which was 90 minutes after 10 o'clock. So we plugged in 90 for our x value, did this ugly math, and we found out they were 54.5 miles away. All right. I would like you to please do these two problems from the textbook. They come from page 303, numbers 2 and 3. Number 2, a little bit of graph space is needed. If you don't have some, you can freehand it. Number 3, you don't need any graph space. You're just writing the equation of the line. Go ahead, pause the video, try these two problems, and we'll get back together in just a minute. Okay, so let's see how we did. So we're going to graph this equation. So we need to find the slope, and we need to find the point. Slope. Well, the slope is typically in this place right here. So it's y minus y1 equals mx minus x1. So what is that number? Well, if you don't see the number next to the parentheses, it means it's one of them. So that slope is a negative 1. And the point, remember, it's the opposite of the x value, the opposite of the y value. So you plot the point, 2, 1. You move the way the slope tells you to move. Now, a slope of negative 1 as a fraction is negative 1 over 1, which means you go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and the reverse of it, up 1 over 1 the other way, up 1 over 1 the other way, up 1 over 1 the other way. And now you have a line, and I missed like half of them, but that's the line. Number 2, write the equation in point-slope form that gives us 2 points. So you need 2 things. You need points, which we have. You need slope, which we don't have. So let's find it. X values, y values, so we find slope. M equals y2 minus y1 over x2 minus x1, giving you 1 over 2. Yeah, and that would be our slope, 1/2. Now we have slope, we have points, we can do it. My y minus y1 equals mx minus x1. Well, slope is 1/2. Pick a point. I don't care. I'll pick this one. The y value is 3. The x value is 2. And remember how these are the opposites, so it's a positive 2 here, negative 2 there. Positive 3, negative 3. This is the equation in point-slope form of the line that goes through those 2 points. And we're done. So, how do you write equations in point-slope form? See if you can write down a little answer. I have a graph here on the screen that kind of represents some of the information from the lesson. So, how do you write the equations in point-slope form? Well, you find the slope and you find the points. Find slope and a point, then plug them in. Into the y minus y1 equals mx minus x1. And that's all there is to it. Homework is there. Again, not many problems. It's couples scattered about. So there's like 3 in the first set, 3 in the second set, 2 in the third. So that's 3, 6, 8 problems total. Okay. This has been lesson 5.3. Thank you for watching.